So, good evening, everybody. I'm Dipanjan Ghosh. In my previous class, already I had discussed about thyroid gland. Now, I want to discuss about parathyroid gland. We know in normal conditions there are four parathyroid glands present in human body, and it remains just under the thyroid gland. And if we go to the anatomy of parathyroid gland, then we can find out that parathyroid gland contain two cells. One is chief cell, another is oxyphage cells. And we know basically chief cells secrete the parathormone. That is the parathyroid hormone. And basically we know the main functions of parathyroid hormone is just to uh, increase the amount of calcium ion in blood. And we know basically if we go to the functions of parathormone, then we see parathormone basically accelerate the absorption process of calcium and phosphate from bone. So, so there are different disorders associated with parathyroid gland. That is the hypoparathyroid, which is known as whenever there is the yes activity of parathormone, that is the hypoparathyroidism. And we know due to yes activity of parathyroid hormone, basically uh, uh, the normal level of calcium and sodium level and potassium ionic level will be disbalanced. As a result, we know titanium is actually produced due to yes activity of parathormone. And we see there are two types of titanic symptom is actually found. One is chopstick sign, and another is the Tausias sign. So in case of chopstick sign, we see the fasciae muscles is muscular contractions is actually found, and in case of the Trausias sign, we see basically the upper extremity, the muscles become spasms basically occur. And due to hyperthyroidism, we know whenever the hyperactivity of P.T.H, we see basically uh, there is some tumor in the parathyroid gland. So basically, whenever due to hyperactivity of parathormone, basically the osteoblastic cell activity become increased. So and it will elevate the calcium ion concentrations to the extracellular fluid, whereas the phosphate ion concentrations become decreased. And if we see the reactions, that is the calcitonin versus parathormone, then we can find out calcitonin is a polypeptide hormone. What have I mentioned? And basically secreted from thyroid gland, and it will basically calcitonin decline the level of calcium in plasma, whereas parathormone uh, is secreted from parathyroid gland, and it will increase the level of calcium. So parathormone basically, calcitonin basically decrease the calcium level in plasma, whereas the parathormone increase the calcium level to the plasma. And calcitonin is secreted from thyroid gland, whereas the parathyroid is secreted from the parathormone is secreted from the parathyroid gland. And we know whenever the calcium ions will be elevated, uh, then calcitonin is actually secreted, and it will decrease or decline the or reduce the calcium level. Now I come to the aspect of pancreas. We know pancreas is a mixed gland because it has a endocrine activity and also to the exocrine activity, and basically it participate to the food digestions to the small intestine. We know, and and uh, and it secretes insulin and glucagon basically. And we know basically whenever we come to the anatomical structure of pancreas, then we see uh, it contain two types of cell, acini and islets of Langerhans acini basically secretes the digestive juices. Mm, and Langerhans islets of Langerhans which secretes the insulin and glucagon. And we see it contains three types of say though nowadays we see there are four types of say present into the pancreas, that is the alpha say 10 to 15%, beta say 30 to 14%, delta say 5%, and if we see then we can see that now pancreatic polypeptide say also presents to the pancreas. And basically insulin secretes alpha say secretes glucagon, beta say secretes insulin, delta say secretes basically uh, somatostatin. Let us say secrete somatostatin. And we know basically hormone gastrin is also secreted from, let us say. And if we go to the structure of insulin, then we see that basically insulin, the molecular weight of insulin is basically 6,000 Dalton, and it contains the two polypeptide chain. One is polypeptide chain A and polypeptide chain B, and A chain contain 21 amino acids, whereas B chain contain 30 amino acids, and that A chain and B chain are attached to each other by disulfide bond, SS bond. And we know basically the functions of insulin is basically it will basically insulin regulate the glucose level, decline the glucose level, and so it will accelerate the glucose. It will convert the glucose to glycogen, and inhibits the glycogenolysis process, uh, uh, stimulate the glycogenesis process, that is glucose to glycogen formations, uh, um, stimulate the lipogenesis process, that is the lipid formations. So it actually prevents the glucose level in blood, and in exchange it will basically accelerate the glycogen level, and that's why it will do its functions. So, and it also already I have mentioned, it also accelerates the fat synthesis process, that is uh, fat metabolism. It will accelerate the fat metabolism. And if we come to the somatostatin, then we know basically it is secreted from the data say of islets of Langerhans, and it is also polypeptide in nature. And we know basically uh, somatostatin inhibits both insulin and glucagon hormone away, and it helps to the um, it helps somatostatin basically uh, gastrointestinal secretions. It will yes the gastrointestinal secretion and its absorption also. And we know basically effects of abnormal sequence of pancreatic disease, basically diabetes mellitus. Diabetes mellitus, we know basically whenever the insulin is yes secreted from beta cell, then it can lead to the diabetes mellitus. And we know basically diabetes mellitus are of two types. One is the insulin type, which is called the type 1 diabetes, and type 2 diabetes. Type 1 diabetes is nothing, it is the insulin dependent diabetes mellitus, which is called the IDDM. Due to deficit of insulin, type 1 diabetes is actually occur, and type 2 diabetes is the non-insulin dependent diabetes mellitus. Okay, so this is two types of diabetes that is due to yes secretions of insulin. And you know, in case of insulin in type 2 diabetes, there is some sensitivity whenever the in case of type 2 diabetes, we know basically insulin resistance here basically what happened, insulin resistance basically occur here. And now I come to the aspect of adrenal gland. We know basically adrenal gland is situated just the superior portions of the kidney, and it has cortex portions and medullary portions also. And adrenal cortex contain three types of three stratum or three are found to the adrenal cortex, basically zona pellucida, zona fasciculata, and zona reticularis basically. uh, within them, Juna glomerulosa, it contains the 15% of total adrenal cortex, and the 6 presents to the Juna glomerulosa basically secrete the aldosterone. Basically secrete the aldosterone, and it contains the aldosterone synthetase enzyme. Uh, and Juna fasciculata basically it contains the majority portion, 75% of total cortex, adrenal cortex. And it secretes the glucocorticoids. Glucocorticoids means, we know glucocorticoids mean cortisol and corticosterone. Though the secretions of that particular phase is actually depend on adrenocorticotropic hormone ACTH, which is secreted from the anterior pituitary, we know. And zona reticularis, it is the most innermost layer of the adrenal cortex, and it secretes adrenal androgen hormone, basically DHEA, that is the dehydroepiandrosterone and androstenedione. And very few amount of estrogen and glucocorticoids also secreted from zona reticularis. And we know basically from adrenal cortex, three types of hormone is actually secreted: glucocorticoids, that is corticosterone; mineralocorticoids, that is aldosterone; and androgen or gonadocorticoids, that is the dehydroepiandrosterone and androstenedione. And if we go to the basically glucocorticoids, the functions of glucocorticoids, then we see uh, the 95% functions of glucocorticoids is actually done by cortisol hormone. And there is some crucial role of cortisol for to the carbohydrate metabolism, because cortisol basically increases the glycogenesis process to the liver. And we know the main enzyme, the one of the main enzyme of principal enzyme of glycogenesis is the glucose 6 phosphatase. And basically cortisol increase the level of glucose 6 phosphatase for the gluconeogenesis process. And if we go to that is one terminology is essential, another is the adrenal diabetes. We know by the absence of cortisol, the gluconeogenesis process is actually increased. As a result, the utilizations of glucose GLA become yes. As a result, the glucose GLA will increase. So what have I mentioned? We know gluconeogenesis is non-carbohydrate to carbohydrate, the process of formation generations of or synthesis of non-carbohydrate to carbohydrate. So whenever the cortisol will increase the gluconeogenesis process, so as a result, what happen? Now it will minimize the utilizations of glucose, and ultimately what happened? Now ultimately the level of glucose become decline to the blood. Sorry, the level of glucose, amount of glucose will be increased to the blood, which is known as adrenal diabetes. So this is all about glucocorticoids hormone. Thank you.